Today, let us continue on the definition of rational numbers. So, rational numbers are, just let me give you the correct way of writing that down. So, rational numbers are any number that can be written in the form of P by Q, where P and Q both are integers and Q is a non-zero integer. So the collection of such rational numbers can be written in the set notation and we call that as Q. So Q, the set of rational numbers, can be written as, so how do we generally write a set? If the elements of the set or the members of the set follow a certain rule or a certain criteria, we write that down. So in this case, this is P by Q. Any rational number is P by Q. Given that P and Q both are integers and Q is not equal to 0. So this is the mathematical way of writing the collection of rational numbers. So few things we should keep in mind about rational numbers. There are infinitely many rational numbers. There is no lower or upper bound of a rational number. That means there is no least or greatest value. 0, which is part of whole number set, is also a rational number because 0 divided by 1 or 0 divided by any integer gives you back 0. So that means 0 can be written in the form of P by Q. And every natural number is also a rational number because every natural number, we can write those as, let's say if I'm talking about 5, we can write 5 as 5 by 1 or 10 by 2 and so on. So every natural number is also a rational number and every integer is definitely a rational number because we already spoke about 0 being a rational number and we also told that natural numbers are rational numbers. So that means 0 and natural numbers all together, which makes a whole number set, are also rational numbers. So what will be the simplest form of writing a rational number? A rational number P by Q, as you can already see, that 5 could have been written as 5 by 1 or 10 by 2 or 30 by 6 and so on. So what is the least possible form of the rational number? The least possible form is where P and Q, they have no common factor. So if we try to figure out the common factor, there is no common factor between P and Q. If that is the case, then we can call this P by Q form is the simplest form or the reduced form of a rational number. While dealing with the rational numbers, you should also keep in mind that every rational number can be expressed either as a terminating decimal or as a non-terminating recurring decimal. Now what do we mean by that? 5 is a terminating decimal number because 5 is basically 5.0. So there is a decimal point and after that it stops there. Similar to that, if you pick up half is 0.5. If you pick up 1 by 4, it is 0.25. Similar to that, you can pick up any other P by Q form and mostly they will either end up in an integer or in terminating decimal. That means your division ends there. What if you pick up a number like 1 by 3 or let's say 2 by 3 or let's say 3 by 11? What happens when you try to figure out the decimal version of these numbers? 1 by 3, if you keep on dividing, you will find that it takes up a form something like this, 0.333 and so on. It does not end. So here 3 is a recurring portion after the decimal point. So the easiest way of writing that or the mathematical way of writing that is 0.3 with a bar on top of it. Similarly 2 by 3, 2 by 3 will be 0.66 and so on. So you can write it as 0.6 with a bar because 6 is the repeating portion of the value of 2 by 3. In the same way, 3 by 11 will result in 0.27, 27, 27 and so on. So in this case, the recurring part does not have a single digit. There is 2 and 7. So the way to write it is 0.27 with a bar on top of it. Now let us try to solve a real life problem regarding rational numbers. Let's say you have been asked to find a rational number between two given rational numbers. So let's say x and y are two rational numbers on the number line, and you have been asked to find let's say n rational numbers which will be in between x and y. So let's say if your x and y are like this, where y is greater than x, we are not bothered about where the 0 is. If 0 is here, x and y both are positive, 0 is here, one is positive, the other one is negative. If 0 is on the right hand side, both are negative, so we are not bothered about the whether x and y they are positive, negative or of varied sign. We are not really bothered about that. So how do you find out n rational numbers in between x and y? So the formula for that is you have to figure out, let's say you're just going to mark a few positions in here, overall n positions, and if you want to distribute these lines or these marks in a way that they are all equally spaced. So let's say the distance between each mark is d. That's a difference. Now the formula to calculate d is the greater number minus the smaller number divided by n plus 1. And once you find that out, the numbers that you are looking for can be denoted as x plus d, x plus 2d, x plus 3d, and so on until x plus nd. Now I'm writing x and y before and after that series. Why I could write it that way? Because the difference here is d, 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 and the last one will also be d. Now let me prove that to you why the difference will still remain as d. Y minus x plus nd, which is equal to y minus x minus n into y minus x by n plus 1. Y minus x minus n, y minus x n plus 1. Now as you know, for any number, if you multiply and divide it by the same number, it remains of same value. So y minus x, I can write it as y minus x into n plus 1 divided by n plus 1. And the rest of the part remains the same. Let's take n plus 1 as the common factor. So here it is n plus 1 into y minus x minus n into y minus x. In the numerator, I can take y minus x as a common factor, and that leaves me with n plus 1 minus n. The denominator remains the same. Going forward, y minus x stays as is. N minus 1 minus n plus 1 minus n plus 1 here, which is y minus x into 1, because both the n's cancel out, divided by n plus 1, which is y minus x by n plus 1. And if you go back to the original definition of d, these are same. So y minus x plus nd is d. Hence proved that all of these are equally spaced rational numbers in between x and y. So I mentioned two things: equally spaced because all of them are spaced by d, and they're all rational numbers because all of them can be expressed as p by q form. Now that leads us to another understanding regarding the rational numbers. We had said that x plus d will be a rational number. That means x plus y minus x by n plus 1 is a rational number. So what we implicitly understood here is that a rational number x plus another rational number d will still remain as a rational number. So that means rational numbers can be added together or subtracted from each other. The result is still a rational number. Now let's say you have been asked to find rational numbers between 0 and 1. And you have been asked to find 4 such numbers. So in your case, n equals to 4, x equals to 0, y equals to 1. So what will be your d or difference? Y minus x by n plus 1, which is 1 minus 0 by 4 plus 1, 1 by 5, 0.2. That means your rational numbers between 0 and 1 will be 0 plus 0.2, which is 0.2. Further plus 0.2, which is 0.4, 0.6, 0.8, and the next number will be 1. So that means you have found 4 rational numbers between 0 and 1.